Hi, good afternoon. We are end user programming for home automation, and today we'll be teaching you how to make your home automation system completely from scratch. Before we start, I'd like you all to close your eyes and imagine your dream home. It's 9 o'clock on a Saturday, and you wake up to the sound of your alarm. It usually goes off at 7 o'clock, but it knows it's the weekend, so it's automatically sets itself to go off 2 hours later than usual. You hear the smooth sounds of Miles Davis, your favorite jazz artist. But since last night was kind of rough, you hit snooze a couple of times before actually deciding to get out of bed. When you finally turn off your alarm clock, at that very instant, the lights in your hallway illuminate and they lead down to your shower, which is running water at your perfect temperature. Simultaneously, the coffee maker downstairs is brewing your exotic Colombian coffee that you specially saved for Saturdays. Now open your eyes. To most, this fantasy home is just that, a fantasy. However, our research group has envisioned a home automation system in which every single electronic appliance in your home can be controlled from a single point, a personal computer. We,
Matt Catanissio,
Raheem Stutberg,
Sam Lichtenberg,
Amanda Ramsey,
and Emily Zhang have created and prototyped an innovative home automation system that does exactly this. So our project has 4 main objectives. They are usability, flexibility, creating a universal platform, and cost effectiveness. Regarding usability, we wanted to create a system that is usable by all people. So that means that you, the technological expert, would be able to program the coffee maker just as easily as your maybe not so technological grandmother. And the concept of speed also falls under usability. We want our automation system to be faster than setting the appliance manually. We also sought flexibility. This means that your devices will be able to perform functions they were previously not able to. For example, when I use my alarm clock, I would wake up to the sounds of Herbie Hancock, and then downstairs there'd be brewing dark coffee. However, when Grandmother Zhang uses the same alarm clock, she'd wake up to her favorite artist, Lady Gaga, and there'd be Colombian coffee brewing downstairs for her. We also wanted to create a universal platform. This means that all of our appliances would be controlled through a single programming paradigm. And last but not least, we sought to create a system that was cost-effective, and this ties into our first goal, usability. We wanted the average user to be able to afford a system of home automation.
All right, so we're going to talk about how we designed our home automation system. We decided to use a program called Scratch, which was developed at MIT a few years ago. It's a visual programming language specifically designed to teach non-programmers how to program. And it's extremely easy to use. The main idea behind Scratch is blocks, which represent segments of code. So instead of actually typing code, users simply drag blocks into their program to make whatever they want. Now we found that Scratch didn't provide all the functionality that we needed, so we decided to use another program called BYOB, which stands for Build Your Own Blocks, which is an extensive extension of Scratch, which allowed us to create blocks that perform specific functions that certain appliances would need to do. Here's an example program that uses 3 blocks. The first thing that it does is just check to see if it's the weekend, and if it is, it would turn on the coffee maker at 7:15 in the morning. Here's a screenshot of our entire user interface. On the left side of the screen is all the blocks that the user would need to use, and they simply drag them to the center and connect them together to make a program. On the right side of the screen is called the stage, which displays the current state of all the devices, if they're on or off, and also displays the current time.
Now, it's important to have a good user interface when designing a home automation system. However, that user interface is useless if it can't actually connect to the appliance itself. and this is where processing comes in. Processing is a Java-based programming language developed in 2001 by Ben Fry and Casey Rios. It was initially created for media and software literacy purposes, but it's also ideal for communication between two programs, which makes it perfect for our purposes. Essentially, when the user inputs which appliances they're altering in BYOB, processing reads this information as a string and looks for specific characters in that string to determine which appliance is being altered and how it's being altered. From there, processing sends this information down a USB cable to an Arduino microcontroller. Now, when we refer to Arduino actually encompasses two parts: hardware, which is the microcontroller, which is essentially a small computer, and the software, which is a programming language that is quite similar to processing but more restrictive. What we did was we created a program in the Arduino software that can read and recognize the input from processing and interpret it and send it to the appliances. And then we uploaded this software program to the microcontroller itself, where it is stored indefinitely. And when processing reads the information from BYOB, it then sends it down the USB cable to the Arduino microcontroller, where it is interpreted and sent to the appliances. And this is a brief overview of our design as a whole. To recap, it starts off at BYOB, where the user inputs which appliances they would like to alter, and this is all the user sees, is this graphical user interface. So for this example, the user would be turning off their lamp. This information is then set, as previously said, to processing, which reads it in the form of a string, interprets it, and then sends it to the Arduino microcontroller, where the program from the Arduino software has already been uploaded and is ready to interpret the information for processing. From there, this information is sent to the appliance.
Alright, so you basically just heard about our software system and how it works. The next step in our process was to create hardware that we can use to interface with the software we had created. So basically we went to Target, we found some appliances that we liked. We brought them back, we stripped them apart, reverse engineered them, and found out how they worked. And two appliances that we actually used were the lamp and the fan. When it comes to the lamp and the fan, basically what you want to do is keep it on the on position. And with the power cord, you separate the hot wire from the actual neutral cable, and then you split the hot wire, and on one side it will be the relay attached to both hot wire ends, and the opposite side will be attached to the input, which is directly connected to the Arduino. And from there you're able to send voltages from the Arduino to the relay to switch it on or off. And the relay is basically an electronic switch, so that's how you're able to control it from the interface.
So the next thing we automated was the coffee maker, which was slightly harder. The coffee maker had 3 different functions: turning on and off, it had button presses, and it had an LCD. So this is the on-off function. Basically, when you turn the coffee maker on or off, it heats up the heating element, which is here you can see with the horseshoe-shaped representation. It heats up the water, which evaporates and then condenses and then drips through your coffee filter, creating your favorite coffee. And we controlled this by attaching relays, just as we did in the fan. And through the relay, we were able to turn it on or off. Next, there are button presses. This is a picture of the front panel of the coffee maker and the picture of the back, which we tied wires on. We were able to control the button presses by connecting their joints to an Arduino, and we were able to mimic the button presses on BYOB. And through this, we were able to control on, off, time, hour, delay, all those settings on the front panel of the coffee maker. And the last thing we reverse engineered on the coffee maker was the LCD. We were originally going to use the coffee maker's LCD, but that didn't work out very well because it turned out we needed a quartz crystal oscillator, which we do not have. So we bought our own 16x2 LCD, and we wrote our own program to control the time. And it is represented on the right of this picture. It says 7:09 a.m.